Hi everyone, and welcome to the Mat 211 review of random variables, both discrete and continuous. So, say that X is the score on a math test by a given student in a class, rounded to the nearest whole percent number. So what that means is if somebody got a 96.8, we would round this to a 97. We want to classify the random variable X, list the sample space, and we also want to describe X. So let's start by listing the sample space. That's often the first place to start because it helps us understand everything else. So we know that a student can get anywhere from a 0 to 100 on a test. And we know that for X, we're going to round all of these to whole numbers. So our sample space from which we draw X, which we can call S here, is going to be the set of 0, 1, 2, 3, and so on up until 98, 99, and 100. So basically it's all the counting numbers between 0 and 100. So 1, 2, 3, 4, 5, 6, etc., all the way up to 100. So that's our sample space. Next, let's look at X. So we know that X is going to be drawn from S. So X is going to be one of these values. It might be 3, it might be 98, it might be any one of those. So first thing, we know that X is a whole number between 0 and 100. And that means that X is discrete. Oops, spelling it wrong. Let's try that again. I'm good at math, not spelling. All right. So we know it's discrete because discrete values are those that are like counting values, 1, 2, 3, 4, etc. They're not continuous where it's all the numbers, all the infinite values between 0 and 100. But so we would notate that as, like 0 to 100, right? So we know it's discrete, but is it finite or continuous? Or finite or infinite, really? So this is going to be finite. And the reason for that is that there are exactly 101 values in here. So we could say that the cardinality of the sample space S is 101. It's 101 because we're including that 0 as well. So since it's not an infinite number of values inside the sample space S, that is, X can't take on an infinite number of values. It can only take on one of 101 values. It's going to be a finite random variable. Now, if our sample space was continuous, or if it was a discrete variable that went from negative infinity to positive infinity, then we would have an infinite variable here, but that's not the case. It's bounded. It's bounded and it's discrete. So we know it's finite. So lastly, let's talk about how to describe X. So X is a rule that assigns a test score to the outcomes. To the outcomes. So that's essentially what we're looking at here. Because remember that in theory, a test score could be anything from 0 to 100, but X tells us that we're rounding it to the nearest whole percent number. So that's what makes this kind of a special variable here. So that's all there is to this problem. Go ahead and make our little box around our answers. There we go. So before I go, I just want to remind you all that if you are looking for any additional tutoring or academic support at ASU, you can go to the Tutoring Center's website, tutoring.asu.edu, to find all of our resources. Additionally, if you're looking for tutoring services for your specific course, we have a tutor search tool, which you can find either from our main website page here or by going directly to the tool at this full link here. And that will allow you to search for tutoring services for your specific course. So thanks so much and have a great rest of your day.